So here we are going to see the next topic, that is garbage collection. Garbage collection means we are destroying objects, that is done by Python in default. Okay. So what is garbage collection? Garbage collection means collecting all unused objects, and the garbage collector will destroy those objects to do memory management, okay, to save the memory, right? So the topic is what? Garbage collection. Garbage collection. So that means what? Destroying unused objects. Destroying unused objects. That is called garbage collection. In general, coming to our Python performs automatic garbage collection. It deletes all the objects automatically that are no longer needed and that have gone out of scope to free the memory space. To process by which Python periodically reclaims unwanted memory is known as garbage collection. The process by which Python periodically reclaims unwanted memory is known as garbage collection. Python's garbage collector runs in the background during the program execution. It immediately takes action as soon as an object's reference count reaches 0. When this garbage collector collects all unused objects, the reference count is 0, then it collects that object and it will destroy it. Got the point? Here important point is what? When an object's reference count reaches 0, Python recollects the memory used by it. That is called garbage collection. So you know, in Python the object has three things. For example, here I am having a variable. In Python everything is an object. Okay, value is an object. That means what? A equal to 50 means what? With a reference, I'm having the value is 50 with a reference. Got the point? That means what? So here we have created one variable with value 50. That means in the memory is saved in this way, the value, then a refers to 50. That means a is having address. Okay, now here the thing is, if you are having an object in Python, we have three things here. So how it will store in the memory means, we'll show you here. We are having three things. First one is, so what is this one? Python object, right? So what is this one? Python object. So first thing is what? Type. So in this way it will store in the memory. Type is what type? So a value, what type it is? Integer type, right? Integer type. Second thing, it will store value. Value of a is what? How much value? 50. Then it will store reference count also. Reference count. What is the reference count of 50? It is 1. Only one variable is reference to 50, right? So that reference count it will store. So in Python we are creating the value, that means anything is an object, right? We are creating in this way the variable. We have initialized the value, means that it will store in the memory in this way. In this way the value will store. So first thing, it will see the type and the value, finally the reference count. Got it? That means Python object have three things. First one is what? Type. Second one value. Third one reference count. When we assign a name to the variable, when we are assigning name to the variable, the type automatically detected by the Python, and as we mentioned above, it will store in this way. The value is declared while defining the object. A reference count is the number of names pointing to the object. What is reference count? The number of names pointing to the number of names pointing to the object. Okay, here only one object we have, one reference we have. Okay, that is A. Now the garbage collection is to release the memory when the object is no longer in use. This system destroys the unused object and reuses its memory slot for new objects. You can imagine this as a recycling system in the computers. Python has an automated garbage collection. It has an algorithm to deallocate objects which are no longer needed. Python has two ways to delete the unused objects from the memory. What are those two ways? First one is reference counting. The second one is generational garbage collection. Generational garbage collection. Now we can see first one, reference counting. The reference are always counted and stored in the memory. The reference count is always stored. How? For example, see here, I have a value 50. Now we have created another variable b. We are assigning a value. Reference is a. B equal to a means b value also 50. So a refers to 50. Then b also value 50, right? So refers 50. Then c value I have given 50. That means c also refers to 50 only. That means what? A, B, C refers 50. That means what? The reference count of 50 value, 50 object is what? 1, 2, 3. The reference count is what? 3. So there is one object there is one object, the reference count of this object is 3 because we are having 3 names, means 3 references. Got the point? How we can know these references? How we can know these addresses? Reference means address only, right? How we can know? For example, we can see, so we are having one file, new file I'm taking here. So here I'm giving a value 50, next b value a, then c value 50. Now how I can know the address of a, b, c, it refers to same value? How I can know? So by using id of variable name a, same way I can see for b and c, b and c. See here we will get output, some give name fi. If you see, the references are same, right? A reference same, b reference same, and c reference also same. Got the point? That means these 3 variables referring same value, means references also same. Then the reference count is what? 3. Got the point? So now what I am doing? So I am checking a is b or not, c is b or not, a is c or not. So now I can check. All should return true, right? Print a is b. So now I am checking. So it happens internally, but I am showing here. A is b, c is b, then a is c or not. See here, we'll get all trues. See, all are getting trues. That means all these ABC variables refer same object. Got the point? So you can know in this way. In this way we can know. Next, now I am changing the a value, b value. Now I am changing the a value and the b value. A value is what? None. None means, so it will store none in the memory. This is what? None. Next, b value false. B value false. So now the reference of A 1, count 1, reference count of B 1, reference count of C 1. So now reference count decremented because the C value is 50, right? So here the reference count 1, here the reference count 1. So you can check here. A equal to none, B equal to false, then print IDs of ABC, Control S, SFI. See here the references are different now. What the point? That means each one reference count is what? 1, A1, B1, C1. Got it? So now whenever the reference count reaches 0, then the object will collected by the garbage collector. How we can know? For example, now here I am deleting C value. Now I am deleting C value. Okay. Then I am trying to print ABC. See the output. So we will get error regarding to C. The name C is not defined. Why? It was collected by the garbage collector and it will destroy it. So this process is done by Python interpreter automatically. No need to do all those things. It internally happens. What the point? So in this way, the reference count will work. So in this way, it is collecting unused objects and it will destroying based on reference counting. When it will collect, when it will delete that element, the reference count is 0. Then it will delete the value. See here. Now here what I am doing. So the C value I am giving some 0 or null or none. Then the 50 value will be here. So nothing is referring. A referring none, B referring false, C referencing 0. Then 50 value, no one referring, no variable referring 50. Then the garbage collector will collect this one, it will delete it by using del method. Sorry, del method of C. Got the point? So in this way, the garbage collector collects the reference when the reference count is 0. Okay, this is the first way. I think you understood about this. Next one, generational garbage collection. So in this generational garbage collection, what happens means, generational garbage collection is a type of trace-based garbage collection. Trace-based garbage collection. In this we are having newly created objects. So that will those are stored in list 0, that is generation 0. Next, if we are having unused objects, means without reference, objects with no reference, those objects are discarded. What the point? That means those are destroyed. So remaining, it transfers to second one, generation 1, that is first list. So here that means the survival of first cleaning, those are transferred here. If it is in this generation also, if you have objects with no references, those are discarded. Next, if you are having used objects, that we transfer to generation 2, that is list 2. So survival of second cleaning. In the second cleaning, when the garbage collector collects the unused objects, means if you have completed the program successfully, if you have executed the program successfully, then that garbage collector will collect the all objects and it will destroy it. That means these objects live until the end of the program. These objects live until the end of the program. After end of the program, the garbage collector will collect and it will destroy. Got the point? That means the generational garbage collection is the type of trace-based garbage collection. It can break cyclic references and delete the unused objects even if they are referenced by themselves. Python keeps tracks of every object in the memory. Three lists are created. Those are list 0, list 1, list 2. So 3 lists are created when the program is run. Those are generation 1, generation 0, generation 1 and generation 2 lists. Generation 0, generation 1, generation 2 lists are created. Here the newly created objects are put into the generation 1 list, generation 0 list. A list is created for objects to discarded. The reference cycles are detected. If an object has no outside reference set, it is discarded. The objects who survived after this process are put into the generation list 1. The same steps are applied to the generation list 1. The survival from the generation list 1 are put into the generation list 2. Then the objects in the generation list stay there until the end of the program execution. What the point? So in this way, the generational garbage collection process will work. Okay, what the point? So that is about garbage collection. We no need to do anything. So internally the interpreter of Python will do. It collects all unused objects and it will destroy based on reference counting and based on generational garbage collection. What the point? That's all about today's session. We will meet in the next session.